All right, hello everybody. My name is Miss Kitis. So today I'm going to go through a lesson that I would teach with my students about how to read the periodic table. So this is probably going to be one of the introductory lessons to how to understand what the periodic table means and why it's organized the way that it is. So when my students walk into the classroom, I'm going to have a do now for them ready, written on the board. And I'm going to ask them, I want them to think about what an atom would look like if they looked through a really good microscope and they were able to see the different parts of the atom and where they were. I want them to think about what that would look like. So I'll tell them I want you to consider the different parts of an atom, which they should have learned in their previous science classes. I'll remind them of the different parts, which are protons, neutrons, and electrons. And I'm going to ask them to think about where they're located and what their charges are. Label that on your picture. And I'll give them a few minutes to do that. And hopefully I'll see some drawings that look like this, which is protons and neutrons in the middle of the atom, which is called the nucleus, and electrons kind of floating around the outside of that nucleus. So I think that they'll be able to do that, especially if I'm guiding them and giving them clues if they're stuck. So after that engagement, I'm going to just go ahead and proceed with direct instruction for the next few minutes. So I'm going to just tell them that the periodic table is basically our constitution for chemistry. It governs all the rules and it explains all of the things that happen in chemistry and in science in general. So today what we're going to talk about is three things that you can get from looking at the periodic table. The first one is the atomic structure of an atom, which is how many protons and neutrons and electrons are in an atom. The second one is the size of atoms, which is how large they are in terms of their mass and their radius. And lastly, we're going to briefly introduce the reactivity of atoms and how you can kind of get an idea of what that looks like just by looking at where atoms are on the periodic table. So as I said, the first thing we're going to talk about is the atomic structure. So how can you tell how many protons, neutrons, and electrons are in an atom just by looking at the periodic table? So for this example, we're going to use carbon. So if you look on the screen here, I have it pulled up and zoomed in. So that top number in carbon, the number 6, that's called the atomic number. So the atomic number starts at 1 with hydrogen, and it increases by 1 for every single atom. So hydrogen's 1, helium's 2, lithium's 3, and so on. So for carbon, it happens to be 6. So that top number, again, is called the atomic number. That is the number of protons in an atom. So the bottom number, on the other hand, it's usually going to have a decimal place, but we're going to round it to the nearest whole number. And it's usually pretty close. It's usually only off by, 0.1 or less. So it's pretty easy to round. So for carbon, it's 12.011. We're going to round it to 12. So that number 12 is the atomic mass. So the atomic mass is the number of protons plus neutrons in an atom. So at this point, I would ask my students, okay, I just told you that the atomic number on the top is the number of protons, the atomic mass on the bottom is the number of protons plus neutrons. How do you find the number of neutrons in an atom? And hopefully I would have somebody say, you just subtract the two. You just do the atomic mass minus the atomic number, and that's the number of neutrons. And then finally, for the electrons, so for an atom in its elemental state, and what that means is just an atom that is neutral and it hasn't been involved in any reactions or anything, the number of electrons is equal to the number of protons in an atom. So again, the number of protons in an atom was the atomic number, that top number, which is 6 for carbon. So that means there's 6 electrons as well in carbon. So after walking through that carbon example, I'm going to ask my students to do the same thing with a different atom. I'll ask them to do it for sodium. So I'll ask them to answer these 5 questions just on their whiteboard, and hopefully they'll get those answers. And of course, depending on how much of the class gets those right or wrong, I would have to stop or pivot or go over certain concepts again. But I'm hoping that, of course, they would mostly get those right. So the next thing I said that we were going to talk about was the atomic size. So the atomic size can refer to the mass and also the radius. So first we're going to talk about the mass. So we have our carbon again. And remember, we said the bottom number is called the atomic mass. That's the number of what? I would probably ask them to tell me what's that mean again. Hopefully they'd say the number of protons and neutrons. So that atomic mass number, it's exactly what it sounds like. It's the mass of an atom of carbon in atomic mass units, or AMU. So a proton is approximately 1 AMU, and so is a neutron. A neutron is also about 1 AMU. So we have 6 protons and 6 neutrons in carbon. That's how we get 12 AMU for the atomic mass. Now, the number of electrons is a little bit more tricky. So electrons are way smaller than protons and neutrons. In fact, they're so small that you don't even have to include them in the atomic mass number. You can't even really measure their mass. So we don't even pay attention to the mass of electrons when we're looking at the atomic mass number. So now let's look back at the overall periodic table. If you look really closely at the atomic mass numbers of all the atoms, remember that bottom number, you'll see that they increase down the periodic table. So, down each row, the one underneath is always greater. And then if you look across the table from left to right, most times, almost all times, the number is going to increase from left to right. So those are the general trends for the mass, the atomic mass of atoms. Remember, it's that atomic mass number, it's that bottom number. If you look at the periodic table, you can see that the atomic mass number increases down the rows, and it tends to increase as you go from left to right as well. So now we're going to talk about the other measurement of atomic size, which is radius. So just like, with a circle and the radius of a circle, it's the measurement from the center of the circle to the outside curve of the circle. For an atom, it's the measurement of the center, or from the center of the atom, which is the nucleus, to its outermost point, which in this case is going to be the electrons, since they're floating around outside the nucleus, as we said when we drew our atoms earlier. So the atomic radius is going to depend on 2 things mainly. It's going to depend on the number of protons in the nucleus, and it's also going to depend on the number of electron shells. So my students probably haven't heard the term electron shells before, so I'm going to have to walk through with them and explain what that means. Imagine a turtle without a shell, actually. They would be a lot smaller. That turtle shell is pretty big. It increases the size of the turtle. It increases the radius of the turtle. Now imagine you put an even bigger shell on top of that shell that's on the turtle. That would make an even bigger turtle with a shell. So as you add more shells to the turtle, it's going to become bigger. From the center of the turtle to the outermost shell, that's going to be a larger distance because you have all those shells underneath of it. It's the same thing for atoms and electrons. So the more shells that you have, the further out those outermost electrons are going to be. You can only have a certain number of electrons per shell. Eventually they're going to become so full that it can't hold anymore, and you need another shell to hold more electrons. The radius of the atom depends partly on the number of electron shells, and the more electron shells you have, the bigger that atomic radius becomes. So how do you tell how many shells are in each atom? You'll see that all the rows are highlighted with different colors. So the rows on the periodic table are called periods. So the first row is called the first period. The second row in orange on this period, or this periodic table, that second row is called the second period. The third row, which is yellow, is called the third period, etc. So each period has the same number of electron shells. So the first period has 1 shell. The second period has 2 shells. The third period has 3 shells, and so on. So the number of electron shells increases as you go down the periodic table. So what does that mean for the atomic radius? I would ask my students that, and hopefully they would say, you're increasing the shells, so you're also going to be increasing the atomic radius. And so, again, I would just nail this into their heads that as you go down the periodic table, you're going to increase the atomic radius. Hopefully they can understand that. This is where it gets a little more confusing. We're going to talk about what it does going from left to right across the periodic table. So in addition to the number of electron shells, the radius also, as I said, it depends on the number of protons. So I want you to think about if you have 2 magnets, one's positive and one's negative. I would ask my students, what happens when you put them near each other? And hopefully they would say, oh, they would, collide and want to be stuck together. It's the same thing with positive and negative charges, with electrical things like an atom. Positive attracts negative. So if you have more protons and more positive charge inside your nucleus, that means that those electrons, on the outer levels, they're going to be pulled in even closer to the nucleus because there's a bigger charge there, a bigger positive charge. That means they're going to attract those negatively charged electrons and pull them closer towards the middle. So that means the atomic radius is going to be less because those outer electrons are closer to the nucleus. That's a smaller distance. So hopefully they'll understand that. This is where I would check to make sure that they do. So I would ask them to consider the following atoms, sodium, chlorine, and potassium. And on their whiteboards or on paper, whatever it is we're using, or online, I would ask them to rank those atoms by increasing atomic radius. So that will test if they understood all of those concepts that I just explained to them. That's the answer that they should get. And, we'll talk about why they got that answer, and, hopefully have a nice discussion that just really reinforces those concepts. And as I mentioned, lastly, we're going to briefly talk about reactivity. That's another thing we can learn about an atom just by looking at the periodic table. So those outermost electrons, they're actually pretty special, not just for the atomic radius, but they're also pretty special for the reactivity of an atom. So the electrons in the outermost shell of an atom, they're actually the electrons that are available to react with other atoms. So when atoms are interacting and there's a reaction happening, those are the electrons that are taking part in that. And those electrons on the outermost shell are called valence electrons. So the reactivity of an atom, kind of being able to tell which atoms it's going to react with and how reactive it's going to be, you can basically kind of get a gist for that just by knowing the number of valence electrons, which is, again, the number of electrons in the outermost electron shell. So then we would go through and discuss how do you tell the number of valence electrons in each atom. So the columns on the periodic table are called groups. I would, maybe check for understanding. I'd say, who remembers what the rows are called? And hopefully they would say they're called periods. So the columns are called groups. And each group has the same number of valence electrons, which is, I would ask them, okay, someone tell me what a valence electron is again. They would hopefully say the number of electrons in the outermost electron shell. I'd ask them, what can these electrons do? Hopefully they would say, react with other atoms, something to the effect. And I would tell them, as you can see in this periodic table that labels the number of valence electrons, it increases from left to right. It increases as the columns go from left to right. So for my final checkpoint, I would ask them to identify the number of valence electrons that each of these atoms have. This one should be fairly straightforward. Alright, so that's the end of my PowerPoint that I would go through with them for my direct instruction. Upon finishing that, I would have them go through an activity that I have planned, which is attached in my written lesson plan. The first part would be completed individually, where they would answer some questions that are pretty similar to the checkpoint questions. And they would turn that in, and that would just let me see, who knows, if most of the class is getting these concepts and which concepts they're understanding and which ones they're kind of getting tripped up on. And then after that, I would put them into groups. And, hopefully if we're actually in the classroom this school year, we could use whiteboards, but, there's other platforms we can use online as well. I would put them into groups, and I have 3 discussion questions, and I would ask them each question one at a time, and I would have them discuss with their group members, and then kind of write like a summarized, maybe bullet point list of all the points that they want to make to answer those questions, and I would go around the room and have them briefly explain their answers to those questions, and it's just reinforcing those concepts. And then I would also have an independent practice, just like a homework assignment that they do individually that just really reinforces and kind of asks some more outside of the box questions that force them to come back to those concepts that we learned in class. So that's how I would kind of run through this lesson with my students. Thank you for listening.